Okay, so Professor Ciufolini, welcome to Padua.
Thank you.
University of
Great
Padua,
pleasure.
Department of Chemical Science. So I have a question about the potential of new tools like artificial intelligence, machine learning in the field of the synthesis of complex organic molecules, and especially in the field of medicinal chemistry. What are the potential in terms of predicting the outcome of the reactions or optimization or again in the design of drugs?
Yeah. So, obviously, I do not know because the field is very young. It has not proven itself yet. There is certainly potential, a lot of potential. We need to wait until the field produces evidence that that potential is real. I can see on paper that there is potential. The moment that the field provides an indication that what they do actually works, at that point I can assure you, everybody will jump on it. So potential is in there. Now the potential has to be demonstrated. A little bit like the combinatorial chemistry of the 1990s. There was a great deal of excitement about that. From now on, we don't need synthetic chemists or medicinal chemists because we will create new molecules by this combinatorial approach. Well, that didn't quite materialize. Okay, that produced advances in ways to do chemistry, parallel synthesis and instruments that allow us to do that, etc., etc. But the original promise of generating lots and lots and lots of new leads, etc., that did not quite materialize. So, as a synthetic chemist with interest in medicinal chemistry, I'm always very eager to see whether new technologies, artificial intelligence or whatnot, are actually capable of facilitating the task of discovering new things. Let's see if that works. Yeah.
Okay. And do you have any advice for students that would like to explore the field of synthetic organic chemistry? Because, the schools in Italy are not so strong, and sometimes people need to travel abroad to make a strong background in this field. What do you suggest?
Well, obviously, traveling abroad is a great thing, and the fact that synthesis may or may not be strong in Italy doesn't mean anything. I often, I often told, for instance, my students in France, if what you want to do is not available here, you go elsewhere where it is available. And I would tell them, a young American who wants to do classical archaeology should not complain that you cannot do that in the United States. Of course not. You learn your stuff, you go to Greece or to Italy, and then you will have all the opportunity in the world to do your classical archaeology. So, students who wish to become trained, who wish to receive training in synthetic organic chemistry may well consider going abroad. The unfortunate problem is that synthetic organic chemistry in academia is strongly out of favor. So everywhere in the world it's extremely difficult to learn how to be a synthetic chemist. At the same time, synthetic chemists are absolutely crucial for the progress of the pharmaceutical industry. So at some point, hopefully, university administrators and public funding organizations will see the lack of wisdom of neglecting synthesis. That said, there are still a lot of colleagues all over the world who are doing synthesis at a very high level, and that could certainly receive students from Padua, from anywhere. I'm thinking about people like Sarah Reisman, at Caltech, Rich Strapon, Berkeley. At Stanford, Justin Dubois, very good synthetic chemist. Viresh Rawal in Chicago. In Switzerland, of course, at Lausanne, Jiping Zhu. And, of course, at the ETH, Eric Carrera. So, in the United Kingdom, it's less clear, but in Germany, there are good synthetic groups.
Okay.
So, for instance, in Aachen, so yeah,
So during the lecture, you were mentioning this KISS principle,
Yes.
keep it simple.
Yes.
So how do you, can you merge this principle with the new expectation of green synthesis? Because in this case, you should apply new
Yes.
techniques, modify your traditional
So,
synthesis, and
absolutely.
sometimes keeping less simple, probably.
Yeah, that is fine. But, a lot of times one has to think that, the greatest green or whatever approach maybe may not be practical. I hate to be, the fly in the ointment or the devil's advocate, but for instance, years ago, there was a great deal of interest about reactions that can be done in water. That's green because we don't use any solvents. I wonder if whoever, I hope it's not your case, I wonder if whoever came up with that idea has ever bothered to find out what it takes to get water in an industrial plant. Obtaining clean water is one of the toughest problems in an industry, in a chemical industry. Not only that, any water that comes out as an effluent cannot just be thrown back into the river or into the lake. It has to be purified. That's horrendously expensive. So, from my perspective, the notion that you can do practical chemistry in water, however green that might be, because it avoids the use of organic solvents, is questionable. If someone figures out a way to do it economically, then hats off to the person. But otherwise, it's not clear. So ultimately, economics determines, what can be done and what cannot be done. We are currently experiencing this wave of enthusiasm about electric vehicles. I wonder if whoever is pushing that has ever considered that to turn every car on the road into an electric vehicle, we will have to quadruple, I believe, the amount of copper that we extract from the earth. It takes about 10 years, as I understand it, to develop a new mine. What could it take? How much work and investment could it take to develop enough mines to quadruple the amount of copper? Not only that, copper, producing copper is not quite that green. Okay? And that's just to start with. The magnets that are used in electric vehicles are based on magnetic materials that utilize rare earth metals. Now, despite their name, rare earth metals are not that rare. But extracting them is problematic. Not only that,
High impact.
yeah, serious impact. Despite that, but beyond that, a lot of these rare earths come from politically questionable parts of the world. So, for instance, the main supplier of rare earths for magnet manufacture is China. Because of various disagreements between China and the West, they have basically shut off the supply of rare earths to the West. And now what? So we don't want them to be able to produce advanced computer chips, so we deny them the use of machines produced in Western countries to make high-performance computer chips. As a consequence, well, fine, then we don't sell you the... Now, I'm not arguing here about the merit or the demerit of these disagreements. I'm just saying that that's the reality.
Sure.
I guess I was talking about gold nanoparticles earlier. I guess the notion that getting gold out of the earth is a green technology is somewhat adventurous. Gold, as you know, is produced by taking gold ore and treating it with cyanide, okay? Because the tetraoro gold complex is oxidized by oxygen very easily, so it becomes soluble, it's extracted out of the ore. That cyanoorate solution has to be treated in a certain way that releases a lot of toxic stuff. So I guess those individuals were proposing to use gold nanoparticles to create more eco-friendly processes. Maybe should have considered all the aspects of the matter. Yeah.
Fortunately, there
So-
are tools now to consider
There are
everything.
tools,
No?
absolutely
like
right.
life cycle assessment,
Absolutely
evaluation,
right.
something like that.
Absolutely, absolutely. So, like everything else in life, things have to be taken in the proper context. And, I often tell my students, or used to tell my students, I don't have students anymore, that probably the pharmaceutical industry is one of the greenest operations on the planet for a very simple reason. Every milligram of waste that they produce, they have to pay to get rid of. And believe me, they are cutting costs like desperate. So anything that improves the economics of producing a pharmaceutical, it's something that I just love. Along similar lines, the notion that you can utilize eco-friendly ethanol produced by fermentation seems to clash with the numbers. When you consider how much it costs to produce ethanol by fermentation, how much it costs to produce it from ethylene. Yeah.
Okay.
So, everything has to be taken in the right context. Everything has potential, but before the potential can be realized, well, there are a number of parameters that need to be
Okay.
addressed.
Thank you very much for
Thank
your
you.
comment. Okay. Thank you.
Thank you. All right.
See you again in Padua.
Absolutely. Anytime. Invite me again. I'll come. Right.